Let's talk about Python. You've definitely heard of it, right? But what you might not realize is that Python isn't just a programming language. Nope, it's really a philosophy, a whole way of thinking that has totally changed the game when it comes to building software. And you've got to ask yourself, why? Python first showed up around 1991. In the tech world, that's basically the Jurassic period. And yet, here we are, and it's absolutely everywhere. Google, NASA, Netflix, it's the engine behind a ton of web servers, data science, and AI. So what is its secret? How is this old language still on top?
Well, the secret, it all comes down to a core promise. See, Python makes a kind of bargain with every single person who uses it. The deal is this: it might not be the absolute fastest language for the computer, but it promises to be the most productive one for the human.
And that's exactly what you see here. The big focus isn't on raw, blistering machine speed. Instead, Python makes this incredible trade-off. It gives up a tiny bit of execution speed in exchange for a massive boost in developer speed. The whole point is to help us, the people, write clean, quality code way faster.
I love this description of Python. It's my favorite. The whole idea is that your code should be so clean and easy to read that it almost looks like a simple, plain English outline of what you're trying to do. And that's not just about looking nice, right? It means you spend way less time trying to figure out what the heck the code is even doing. Just look at this. It says it all. On the left, you've got that C-style syntax. It's a sea of brackets and semicolons. It works, but it's cluttered. Then look at the right. That's Python. It just uses clean indentation. There's no extra junk. It's so simple, it practically forces you to write code that other humans can actually read.
Okay, so if that clean syntax is the grammar of Python, then what are the nouns? What's the actual stuff we're working with? Well, that brings us to Python's core data types. This is your essential toolkit.
Now this is a really key idea to get your head around. In Python, a variable isn't just a simple box you stuff a number into. No, it's more like a name tag you slap onto a really powerful object. And every one of these objects comes with its own built-in set of tools or methods that are ready to go right out of the box. And these three are the absolute workhorses. You've got strings for all your text, you've got lists, which are your go-to for keeping things in order that you might need to change later. Think of it like a grocery list. And then you have dictionaries, which are awesome for storing related info, kind of like a digital contact card where you look things up by a key, like name or email.
Okay, this is a big one. It's a key difference you have to know. Some objects, like strings, are immutable, meaning they can't be changed. When you think you're changing a string, you're actually creating a brand new one from scratch. But other objects like lists are mutable. You can change them right there, in place. Getting this difference is absolutely fundamental. So, we have our building blocks, our stuff. But let's be real. How do you go from just a few little pieces of data to building a massive, complex application without the whole thing turning into a tangled mess? Well, that's where Python's structural blueprints come in.
Python gives you this really natural ladder to climb as your projects get bigger. You start small by packaging useful bits of code into reusable functions. Then, as you have more of those, you start grouping related functions together into files called modules. And when you're ready for the big leagues, you create your own custom blueprints for objects using classes. It's a path for growth.
And with classes, you get this bit of magic called inheritance. It's amazing. You can create a general blueprint for, say, an employee. Then you can create a chef and just say a chef is an employee, but with a few extra cooking skills. And then you can say a pizza robot is a chef. It gets all the employee stuff, all the chef stuff, and adds its own robotic features. You only have to write the common code once. It's all about specializing.
Of course, in the real world, stuff breaks. No matter how perfectly you build your program, things are going to go wrong. A file you need might be missing, a network connection could just drop. Instead of just letting the whole thing come crashing down, Python has a super elegant way to handle the unexpected.
So instead of just crashing and burning when an error pops up, Python raises an exception. Think of it like it's throwing up a red flag. This gives your program a chance to see that flag, catch the error, and decide what to do next. Maybe try again, or just shut down gracefully instead of exploding.
And this right here is your main tool for doing that. You put your risky code, the stuff that might fail, inside the try block. If anything goes wrong in there, Python immediately jumps down to the accept block. It's literally a safety net. Your code is the high-wire act, and the accept block is there to catch it if it falls.
But what about stuff that absolutely has to happen, no matter what?
Like, you have to close the file to make sure your data gets saved, whether there was an error or not. Well, that's what Finally is for. It's the cleanup crew. It is guaranteed to run at the end every single time.
All right, so we've seen the pieces, the blueprints, and the safety nets. Now, let's pull back the curtain a little bit. Let's pop the hood and take a look at the magic engine that makes all of this work so smoothly.
So when you hit run, your Python code doesn't just go. First, it gets automatically compiled into something called bytecode. It's this intermediate step that can run on any computer. Then the Python virtual machine, the PVM, actually runs that bytecode. The key takeaway for you, this all happens invisibly. So there's no separate annoying compile step like in some other languages. It makes development super fast.
Here's another piece of that under-the-hood magic, dynamic typing. What that means for you, the developer, is that you just don't have to worry about declaring what type of data a variable will hold. You can have a variable x be the number 5, and in the very next line you can make x the string hello. Python just figures it out. It's flexible, and it keeps your code short and sweet.
And all of this brings us full circle, right back to that core philosophy, that big trade-off. Because Python is doing so much for you behind the scenes, managing memory, figuring out types, running things in a virtual machine. It can be a little slower than some other languages. But look at the payoff. The time it takes for a human to develop something is slashed.
This quote right here just sums it all up perfectly. Let's be honest, for most of the stuff we build today, the real bottleneck isn't the computer's CPU speed, it's our speed. The time it takes for us to build, to fix bugs, and to maintain things. Python makes a huge bet that our time is the most valuable resource. And for millions of us, that bet has paid off big time.
So when you zoom out, Python's incredible success really points to a massive shift in how we think about programming. Computers just keep getting faster and faster, making machine time cheaper every year. But our time, human time, that only gets more valuable. So it leaves you with this question. What happens to the future of technology when our most important tools are designed first and foremost, not for the machine, but for the human mind?